Hi science teachers, welcome to Science Teacher Summer School, Episode 2. I'm Kent Louie, and something you may not know about me is that I once took harmonica lessons. This was back when I was young, single, and had time, and was trying to find ways to fill that time up and meet people. It was fun, and I remember how to bend notes on a harmonica, which is pretty cool. Now, let's get to work. What's the science skill you want your students to have learned after leaving your science class? For me, it's knowing how to formulate and communicate a good scientific conclusion or argument. It sounds simple, but requires a whole bunch of other skills, like analyzing data and connecting textbook knowledge to real context. Also, it's not something that's really taught in science textbooks. Many textbook labs, for example, just have a list of discussion questions that teachers automatically assign to students at the end of each lab. So, a few years back, I thought there's got to be a better way for students to reflect, write, and discuss their conclusions in their labs. So, what would this look like? In my classroom, I've been using something known as CER, which stands for claim, evidence, and reasoning, which has been awesome. A claim is a conclusion or argument that I come up with. Evidence is the data that supports that conclusion, and reasoning is the scientific explanation for that conclusion. Now, let's consider this textbook lab activity, where students explore what happens to current when the lamp is switched out for lamps of increasing voltages. In other words, we want to observe the effect that higher voltage lamps have on a circuit's current. What I do in my classroom is I have students write out CER statements. A CER statement for this lab could sound like this. When lamps of increasing voltages are connected to a circuit, then the current will decrease. According to our results, when 6 volt, 12 volt, 24 volt, 36 volt bulbs were connected one at a time in a circuit, we measured a current of 2 amps, 1 amp, 0.5 amps, and 0.33 amps respectively. One explanation for this result is that bulbs with larger voltages have larger resistances, and larger resistances prevent the flow of charge through a circuit, which results in a lower current. Now, your students can definitely write a CER statement like that. They just got to work up to it. And consider the benefits of getting students to write CER statements instead of answering lab questions at the end of a textbook. For one thing, students have to analyze and make connections between what they know and what they're observing. There's also less plagiarism because it's not so much about getting an answer to a question as it is about communicating what they found out and how they know it to be true. Now, perhaps you're wondering how you can get started with CER. One thing I do with my students at the beginning of the year is a CER activity that has students learn a little bit about me and practice writing CER statements at the same time. In this activity, I show students things I have brought from home. Things like this guy, a portable CD player from my youth, anti-shock, if you remember what these things are. I show them one of these guys. Remember these guys? Floppy disks back from the 90s. I grew up with these. And this guy over here, one of Apple's very first digital cameras. Looks like almost like a set of binoculars. And then I have students write a CER statement about me. I actually give them 10 objects to look at. And then I give them some prompts to help them come up with a conclusion about me. I ask them for a claim. And the claim would be, what is something you can conclude about my personality? Okay, and the evidence would be, well, what items support that conclusion about my personality? And finally, reasoning. What is an explanation as to why Mr. Louie has this personality trait? For more help getting started with CER, I'm also coming out with an ebook that will provide a collection of notes, worksheets and prompts, and lab activities, hopefully, that students can do to practice analyzing data, making connections and coming up with conclusions. That's all the time we have for this episode. Join me next time when I'll be talking about how to answer that question we all ask students at the beginning of the year. What is science? You don't want to miss it. Until then, stay safe, see you again soon, and remember to science everywhere and every day.